Now let's see whether we can get the slides up. Oh. Well, as you probably feel, the data center now throughout the world is fundamentally changing. We are actually in the midst of a major inflection point of IT, and that change is triggered by a new wave of applications. There are several drivers behind this new wave of applications. First of all, is so-called democratization of application development through toolkits or APIs, which cause an explosion of applications available. Secondly, is due to the so-called consumerization of IT, because the end users in their private life are accustomed to just download just about every application to any mobile devices, which leads to their expectation to the corporate IT also to download any application to any devices. Thirdly, there is a new breed of application that is actually a major theme of this conference, is the big data and the business intelligence analytics. This offers a tremendous amount of value to the business, while the real implication to the IT is still to be defined. Of course, in the data center, there are still these so-called legacy applications, from communications to databases, to ERP, to HRM, to CRM, that are still mission critical. There's also another thought coming to mind. That's the way the business consume these services. Several years ago, in the context of cloud computing, there was considerable amount of discussion about consuming infrastructure as a service. That has evolved considerably. Actually now, businesses can get just about any databases, emails, collaborations, or a number of other services from cloud-based service. While there are some concerns among IT people, say, what is this going to cause the future of IT? But many also believe this gives the IT a chance to provide even more value to the business. But the evolution continues, and all these new applications also start to create new demand for the data center infrastructure. In a cloud computing environment, you tend to run multi-applications, multi-tenants. That means you no longer have the luxury to tailor your infrastructure to suit the workload of a particular application, like what people were doing during the dot-com time or the early 2000s. Instead, the applications may be provisioned to the data center infrastructure and then dynamically removed when that application has been run. So that means the infrastructure has to be able to get more programmable so that they can be tweaked, provisioned to suit the particular application being run at the time. The application developers is also getting more sophisticated. While virtualization tends to be a very flexible tool for people to improve utilization, but some of the new algorithms have been developed in such a way that they can completely exhaust all the productivities, or called juices, out of the data center computing, storage, or networking equipment. So why wasting additional CPU cycles to run virtualization? And yet, virtualization is still being used in many parts of the data center. So that pretty much just means the infrastructure providers has to do a real good integration seamlessly integrate the physical environment, or called bare metal, and virtual and the cloud environment requirement together. And furthermore, these developers don't want to confine the capacity or the performance of their application to a fixed number of resources. They want to make it agnostic. So by the time the deployment happens, the performance and the capacity is only determined by how much resources can be drawn upon to run those particular applications. And as such, the data center infrastructure has to be able to be managed like a pool together in a resource pool, and then dynamically being allocated based on any particular application and special requirement. Furthermore, because almost all the public cloud are based on the horizontal scale-out architecture, so a number of new applications, like Hadoop in big data, tends to use a scale-out architecture to get additional capacity and performance. That means networking is started to get included as part of the performance equation. That makes the networking latency, networking bandwidth, more and more important than if comparing to if the application is only confined and being computed within a particular server or mainframe platform. And finally, we are living in a world of many clouds. That means that the IT has to up a level and start thinking about securely managing a multiple cloud or a hybrid cloud type of environment. And that brings security squarely into the equation. So Cisco offers we call unified compute data center technology, basically in 3 areas. The first one is called unified computing, using the modular stateless computing and serve the application acceleration. The second area is unified networking, which we provide policy-based, scalable, secure networking fabric. And most recently, we even announced our hybrid cloud technology called intercloud. And limited by the amount of time this morning, I won't get into that area. But I will dive a bit deeper into the first 2 areas. Traditionally, in the data center, as I said, particularly during the .com and early 2000, in the data center, we tend to have different silos to run different application or workload, ranging from running legacy apps, running web apps, all the way to the dev test kind of a sandbox environment, or all the way to data desktop virtualization. This may have served us well in the past, but nowadays, due to the challenge to IT, to continually reducing the total cost of ownership and also being more agile, this is no longer sustainable. What we want is to have a unified platform which can dynamically satisfy, seamlessly provide the requirements of these different environments so that it's much easier to manage, much easier to provision, and then achieve the ultimate purposes. So 5 years ago, Cisco rolled out we call unified computing systems. The whole idea is based on the Intel x86 reference design, whether they are in the Blade form factor, whether they are in the Blade form factor or in the Rackmount form factor, the hardware is designed completely stateless. And all the parameters, including addresses or the software version numbers, any parameter you can possibly try to customize a particular server software, hardware, you capture them in software. I will come back to that. But Cisco went ahead and built a switching network to interconnect up to 160 such 2-socket, 4-socket server together, and then put a piece of management software called UCS Manager to manage this cluster of resources. And on the northbound, it has a industry standard API so that you can put the application on top of it, or higher level management software on top of it, or maybe even user script. With such an arrangement, since the hardware is stateless, so the subject matter expert in the customer's data center, whether they are the server administrator, whether they are the networks administrator, whether they are the storage administrator, or maybe even they are security expert, they can sit down and based on the policy of their company, their enterprise, their institution, or their organization, to specify precisely what are those parameters that should be specified. And this piece of software essentially become a software abstraction of the server you wanted it. In fact, you can even optimize this set of parameters for a particular application, whether for performance reason or for economics reasons. You may decide it's most economical for you to run ERP in a Microsoft Windows environment on top of Hyper-V hypervisor. Or you may decide to run VDI. It's best to run using Citrix, the Zen desktop, and running in a Linux environment on top of maybe VMware ESX. You can specify those. Then when the stateless hardware get delivered, since they are stateless, they are all identical, you just grab the appropriate service profile, you instantly customize the hardware to the way you wanted it. And from here, the same principle, if you follow some of the recent Cisco imaging, we raise the same style to the higher level to look over a end-to-end cloud computing environment in an architecture we call Application-Centric Infrastructure, which will collect all the detailed requirements to run a particular application. And these are the detailed requirements that needs to be provisioned to all the resources in the data centers, even though the apps is specified based on a web tier type of requirement. The software, the policy controller, based on the application profile, will translate these application-based requirements into detailed infrastructure instruction. Then the operator just grab the appropriate application profile and push it down to the entire data center to provision the network, the compute, and the storage devices. So with such a capabilities, now instead of having multiple silos to run different workload, different requirement, through the appropriate service profile you choose, now you can run basically on one single unified platform and to run multiple apps on this thing to achieve the highest efficiency. Now, whenever you talk about running apps doing compute, you have to think of data. Particularly important for this conference. While data, if you look into it, also spread a spectrum from the so-called cold data. Those are more than 90% of the data we human produce these days. Once created, we store them away. We never touch them anymore. These are the cold data. Storage people love them. But the other end of the spectrum is called hot data. These data are being used by analytics to constantly analyze, to mine them, trying to extract as much intelligence out as possible. And these apps, these analytics are very I/O intensive. Again, the access time to the data become critical for the performance of running such apps. And with all the emergence of the critical role of these business intelligence analytics, Cisco decided now in the traditional computing architecture, it's time to introduce another layer based on the solid-state flash, which has an access time more than 2 orders of magnitude faster than the spinning media, and yet with the capacity started approaching that of the traditional spinning media, and to incorporate a layer to accommodate all these hot data as part of the computing platform. So the unified computing system from Cisco continued to evolve from the original founding principle of providing application centricity, the operational simplicity, and being the platform for IT innovation. Now we even start to address the new data velocity and scale requirements, and to integrate the application acceleration into the computing domain. So because of this, being the ideal platform to run big data, within UCS, we even offer reference architecture we call Common Platform Architecture for Big Data. Single SKU, small, medium, large. We have pre-tested and pre-validated for predictable performance. And we cover all different variations of big data analysis, from Hadoop, NoSQL, to MPP. And we have white papers and reference architecture tailored for just about every big data software vendors, and to provide the best price performance for the requirements. And with UCS architecture, each UCS manager can manage up to 10 racks of servers, up to 160 2-socket, 4-socket servers. And then we have the next level management software called UCS Central, which can manage multiple UCS manager domains, literally up to more than 10,000 nodes. And this provides a very scalable platform to run big data. Furthermore, while a lot of these new breed of unstructured big data is interesting to provide intelligence, but data centers still need to run the traditional structured ERP data. So while the big data, for example, Hadoop, tend to use we call UCS C-series. These are the rack mount boxes. The traditional legacy mission-critical software tends to be built using the blade form factor called UCS B-series. Under the same UCS manager, we can manage both sides, which make the ultimate reporting of the analytics become much easier and much more productive. And furthermore, to integrate with the latest Cisco application-centric infrastructure, the next generation, remember that top of the switches, which interconnect all this cluster of UCS server together called Fabric Interconnect, we'll be using the new Nexus 9K technology, therefore it's ACI ready. And yet, it continued to use the same computing and the storage infrastructure underneath. So it's excellent investment protection. So the way in a UCS-centric ecosystem, the way we put it, from UCS all the way to this application-centric infrastructure, the approach goes as follows. First of all, you define the application profile. Based on the application you want to run in the data center end-to-end, you collect all the associated policy requirement in this application service profile. You can use a level of UCS manager software we call UCS Director to configure, automate, and provision such an application profile. Once it's done, then through the UCS Director, which is a single pane of glass for you to manage, you can, through the API, to communicate with the next level 2 pieces of management software. One is called Application Policy Infrastructure Controller, or APIC, which will be using the application profile to provision the entire networking requirement as well as security requirement, while delegating the provision and the management of compute and storage resources to the UCS manager. And from there, you can provision and set up the entire environment. Now, notice in this whole description, there is no assumption of what hypervisor you are using. In fact, you may be deploying application to be run on, say, Microsoft Hyper-V, or to run on the VMware ESX, or maybe even onto the bare metal. It doesn't make any assumption whether you are using virtualization at all. This is different from some of the solutions currently in the market, which assumes you are networking virtual machines, which is more limited. Second thing to notice here is with this approach, you don't have to touch the individual compute or switch boxes. So for example, for those of you involved in networking, sometimes to construct the so-called access ACL, the access control list, on a per switch basis is really a big pain. Now with the ACI methodology, once the application profile collect all the requirements, it will automatically translate to the next level detail and do all the provisioning for you. So you don't have to touch individual boxes anymore. But probably the most important thing in this methodology is it actually makes the entire IT department, whether you are experts in managing servers, storage, networking, security, or overall management, all working together for an application. This is dramatically different from some of the solutions currently in the market, which tends to favor some part of the IT at the expense of some other part. The ACI methodology actually encourages all the subject matter experts in the IT working together to provide the most secure, most productive computation on a general framework. So this is a quick 25 minutes introduction of this new era of methodology, particularly when it comes to apply to the big data analytics type of environment. So with the time limit, thank you very much for this.